Hello students, welcome to Sreenath Academy. In this video, we are going to discuss the 12th chapter, which is Exponents and Powers from 8th class math. So, my name is Karthik Nune. We are creating videos on all chapters and all subjects from class 6 to class 12. So, please do subscribe our channel, also like and share our videos. Also follow on Instagram and join our Telegram channels. So, let's begin this video, students. So, what is our present chapter name? That's our present chapter name is Exponents and Powers. So this is our present chapter name, students. So in this video we're going to discuss some topics, some concepts, and some example problems. We're not dealing with the exercise problems. If you really want exercise problems to be solved, then please feel free to comment below, so that whenever we are getting the enough number of comments from you, then we will definitely upload the videos on all problems, on all exercise problems, especially exercise problems to be solved and their videos in our channel, students. Okay, let's begin this video. In this video we are going to discuss about the first thing is about introduction, next thing is powers with negative exponents. So what happens when there are powers with negative exponents? After that, we will discuss about laws of exponents. What are the laws we are having? After that, we will do solve some problems, example problems. After that, use of exponents to express small numbers in standard form. So how to express small numbers and standard forms? By using the exponents. So that's what we are going to discuss in this video, students. Next thing is comparing very large and very small numbers. So how we will compare the large and small numbers? That's it, students. So this is our whole chapter. So this is the whole topics and the concepts and the example problems we are going to dealing now. Okay, students. So our chapter overview is completed. Hello, students. Now we will discuss the introduction and powers with negative exponents and try this and do some problems like this, students, in this video, students. Okay, so first thing is our chapter is exponents and powers. So in this chapter, in the introduction, so do you know what is the thing? Mass of earth is 5 into 5. How there are so many zeros. How to call that number? So somewhat this is a difficult task to count this number, students. So we have already learned in earlier class how to write such large numbers. So this is a very big number. What it is? Mass of earth. How much it is? How much kgs it is? So it is basically 5,970, 000. How many triple zeros? 1 2 3 4 5 6 7 triple zero, students. 3. It is so big number. 4370. So that mass of earth is this much of kgs. So it is very difficult to count now. So we know how to express. We have already learnt in our previous class that how to express this type of large numbers conventionally using exponents. So using exponents, we can write this number as how much? That is 5.97 into 10 to power of 20 or 4 kg. So simply this is very simple to call now. 5.97 to 10 to power of 27 kilograms. Okay, students. So we learned how to express this type of large numbers in this exponent form, students. So here we are having 10 power 24, which means 10 raised to 24 times. How many times? 10 raised to the power 24. Here, what is the power of 10 power 24? That is 10 raised to the power of 24. So if you now we will understand about 2 power 5, then surely you will understand that 10 power 25 later. So first 2 power 5, which means what? Which means 2 raised to power 5. So which means 2 power 5 means what? That is 2 into 2 into 2 into 2 into 2. So 2 power 5 means we have to write 2 5 times. We have to multiply 2 5 times, like that, no students? So this is how many times? This is 5 times. Similarly, if there is 2 power m means that is 2 into 2 into 2 into and so on. How many times? M times you have to. How many times, students? M times you have to write it. So this what about the powers, students? Okay. So let us find. So this is about the sub. If m is a positive number, if like 5, a positive integer like 4, 5, 24 or anything, we can write like this. We know this all about stuff in the previous class. Now if m is negative integer, what happens if m is negative integer? What happens, students? Now we'll start with a very small letter. Suppose if m is equal to minus 2, then what happens? 2 power m, so that is equal to 2 power minus 2. Then in this case, how we will do, or how we will solve, or what is the value of this 2 power minus 2? That's what we are going to learn now, students. Okay, we are familiar with the positive integers. Whenever there is a power of 5 or power of 10 or power of 24, whatever it may be, whenever it is a positive integer, we know how to write it, we know how we call those and how we have to multiply it and all those stuff. Now we are going to learn whenever the power is a negative integer, how to solve it, or what is the value of it. That's the thing we are going to learn now, students. So powers with negative exponents. Okay, students. So here there is 10 square now. So we know 10 square is nothing but 10 into 10. We have to write that 10 here, 10 raise it to power 2. Power 2. And we have to write 10 into 10, which means 2 times. Why? Because 2 times. Why? Because is there is a 2 in the power. So similarly, whenever there is a 10 square, we are writing it 10 into 10. That is, it becomes 100. So whenever there will be 10 power, or whenever the one power is decreased by 1, then you will get 10. So we can write 10 as the 100 by 10. Value of the, what is the value of 100 by 10? 100 by 10 is nothing but 10 times are 100. No, so the value is 10. So that is equal to 10 power 1. Here that is the scenario. So the power is decreased by 1. Now again the power is decreased by another 1. So finally after 10 power 1 you will get 10 power 0. So 10 power 0 value is which? That is 1. We know it. So how you will get in terms of tens? Dividing 10 by 10, you will get 1. Okay, students. So in this way, if you further, here there is 10 square, we have decreased the power up to 1. You have decreased the power by 1. So then it will become 10 power 1. Again you have decreased the power by 1. Then it will become 10 power 0. If you again decrease the power by 1, then it will become 10 power minus 1. Then what is its value in this scenario? That's what we are going to learn, students. So continuing the above pattern, you will get 10 power minus 1 equal to 1 by 10. So basically in this case, whenever the 10 square, there is the answer is 100. Answer is 100. Whenever we have decreased it, so we can write 100 as how much? Can write 100 as, we can write 100 as 1000 by 10. So 1000 divided by 10 means 100. No. So whenever there is a 10 square, it is 1000 divided by 10. So whenever we have decreased the power 1, then what happened? It is 100 divided by 10. So whenever we have decreased the power 1, it becomes 10 by 10. So what you are observing? So whenever the power is decreasing, the numerator value is decreasing by 10 or not 10. 10 is decreasing. So here 10 lost, it will become 100. Again 10 lost, it will become 10. Again if you 10 lost, what happens? It will becomes 1 by 10. That is the pattern. So 10 power minus equal to 1 by 10, students. So this what the pattern is, right? Okay, that's okay. Next, if again the power is decreased by another one term, what happened? What happened? What is the smallest number than 1? So here 10 power minus 2. So again what happened here? 1 by 10 divided by 10, students. So we have to write it like that. So So 10 power minus 1 is 1 by 10. Okay students, so now 10 power minus 2 becomes what? So basically 10 power minus 2 is 1 by 10 divided by 10 students. So that it is 1 by 10 into 1 by 10, that is 1 by 100, that is equal to 1 by 10 square students. Okay, so I will write here. So basically whenever there is 10 square, we can write it as the 100, we can write it as the 1000 by 10. So whenever there is 10 power 1, we have decreased the power by 1, it will become 10, we can write it as the 100 by 10. So whenever again the power is decreased by 1, it will becomes 10 power 01, that we can write it as the 10 by 10. Again, if it is further decreased, power is further decreased by 1, it will becomes 10 power minus 1. Then what is the value is? That's value is, we have to decrease, that will becomes 1 by 10. So this is the pattern students, 1 by 10. So if further 1 is decreased, that is 10 power minus 2. In this case, what is the value? So basically the value is 1 by 10 square students. Here what we have done is 1 by 10 divided by 10. We have to again divide it by 10 students. By this way you will get the answer. So basically 1 by 10 divided by 10. So 1 by 10 into 1 by 10. So that is 1 by 10 square. If you further decrease it by 1, that is 10 power minus 3. So it will give how much? That is again 1 by what he has given us, 1 by 100 divided by 10. So divided by 10. So that is 1 by 100 into 1 by 100 into 1 by 10, that is 1 by 10 cube students. So what is basically happening here? Here what happened in the numerator, we have decreased. First there is 1000, when it will becomes 100, then it will becomes 10, then it becomes 1, then next thing is 0.1. no, next thing is 0.01. So which means what happened in every scenario? So from this to this, what happened? This is 1000 divided by 10. So that will becomes 100. So whenever the 1 is decreased, this value is, that previous value is divided by 10. So whenever one power is decreased, that previous value is divided by 10. Here again what happened? Here again 100 by 10. Okay students, again divided. So here again 10 by 10, that is 1. Here again 1 by 10, that's why that is 0.1. 1 by 10. Here again 1 by 10 means 0.1, that 0.1 by 10, so that will become 0.001. 0.001 or 1 by 10 square. So that's why that is 1 by 100. So we dividing that 1 by 100 with 1 by 10 students. So finally one thing students we have to remember is very simple students. So just simple students, if there is 10 square, we have to write as 10 into 10. If there is 10 cube, we have to write as 10 into 10 into 10. If there is 10 power minus 2, we have to write it is just 1 divided by 10 square. That's it students. Just for minus, we have to write it as the reciprocal. If there is 10 power minus 3, we have to just write it as 1 by 10 cube. If there is 10 power minus 7, simply write it as 1 by 10 power 7. That's it. If there is 10 power minus 19, just write it as 1 by 10 power 19. It's so simple students. So whenever there is a negative number, whenever there is a negative power or negative exponent, their negative integer is there, just you have to write it as 1 by 10 power 19 students. So this is the scenario we have to understand students. So this is the case whenever there is power with negative integers. So what is equals to 10 power minus 10? So 10 power minus 10 is nothing but that is 1 by 10 power 10. That's it, simple students. So simply we will do for it 3 cube. So 3 cube is how much? That is 3 into 3 into 3. That will give rise the 27. Now whenever we are decreasing it power 1, it will becomes 3 into 3. that is equal to 9. We can write it as the 27 by 3. So what happens, that previous value is divided by 3. Previous value is divided by 3, so that you are getting it. So whenever you are decreasing further one, that 3, that is equal to 3. So how can we write that as we are dividing that previous value by again 3, that is 9 by 3. So this is the thing. How we are getting is by dividing 3. So whenever you are further decreasing it, it becomes 3 power 0. So how you will get is that 3 power 0 is equal to 1. So that is by 3 by 3. This is the value. What we are doing is, in every case, we are dividing the previous value by 3, students. So simply if you further decrease by 1, what happens? That is 3 power minus 1. So what happens? So again you have to divide the previous number with 3, students. So it will becomes 1 by 3. 1 by 3. Okay, students. Next, if we further decreased by 1, okay, 1, that is 3 power minus 2. Again you have to again divide this term with 3. So that it will becomes 1 by 3 divided by 3. So that will becomes, or if you that will becomes 1 by 3 into 1 by 3, that is equal to 1 by 3 square. What we are doing is, whenever we are decreasing the power 1, just we are dividing with 3. We are dividing the previous value with 3. In this case, the previous value with 3, the previous value with 3, the previous value with 3. So that is the thing. Whenever the power is decreasing by 1, we have to divide the result of the previous one by 3. Then you will get the answer. So in this way, finally, what is our conclusion? What is our conclusion is 3 power minus 1 equal to 1 by 3, comma 3 power minus 2 equal to 1 by 3 square, comma 3 power minus 3 equal to 1 by 3 cube, students. So whenever there are negative numbers on the powers, don't worry, whatever the number is here, whether it is the 3 or whether it is the 10, whether it is the whatever it may be, just you have to write the 1 by and what is the power as the positive integer. That's it, students. So these are the things. So finally, what is our conclusion is this, students. It is very important. So in general, a power minus m equal to 1 by a power m. So this is the most important thing, students. So where in this case m is what? M is positive integer. M is positive integer. Okay, students, and a is what? And a is a non-zero integer. A is a non-zero integer. So whenever a is a non-zero integer and whenever m is a positive integer, then a power minus m equal to 1 by a power m, students. Okay. Suppose, for example, m equal to 3, students. It is a positive integer. No, it is a positive integer. So now we will take next thing is a is equal to how much? Let's say 5. It is a non-zero integer. Now a power m is minus m is equal to 5 to the power of minus 3. So value is how much? So this is very simple. According to this formula, that is 1 by 5 cube. That's it, students. So in this way you have to write it, students. Okay. So and one more important thing is a power minus m is multiplicative inverse of a power m. So this is the one more thing. Sir, what multiplicative inverse is? Suppose if you multiply 2 into 1 by 2, what is the answer? The answer is 1. Okay, if you multiply 13 into 1 by 13, what is the answer? That is 1. So we called 13 and 13. We say 13 is multiplicative inverse. Multiplicative inverse of 1 by 13. 1 by 13, students. So this is the whenever you are multiplying two numbers or any two, then your answer is 1, then we call that both numbers which you have multiplied as the multiplicative inverse. Suppose if a into b is equal to 1, then if a into b equal to 1, then a is called multiplicative inverse. What it is? Multiplicative inverse. I am not writing fully, inverse of b. So in this scenario, a power minus m is the multiplicative inverse of a power m, students. Okay, so why? Because whenever you are multiplying a power m into a power minus m, your answer will be 1. So if you want example, I will show you. Suppose a power m, here the case is minus 3. Here in this case, a power minus m is equal to 5 power minus 3, and a power m equal to 5 cube. Then what about a power minus m into a power m? That is equal to 5 power minus 3 into 5 power 3. We know how to write 5 power 1 by 3, that is 1 by 5 by 3. So 1 by 5 cube into 5 cube. So 5 cube 5 will cancel, answer is 1. So whenever the answer is 1, then those both terms are called as multiplicative inverse. So a power minus m is multiplicative inverse of a power m, students. Okay, can you understand it? So that is the thing, students. Okay, so here find the multiplicative inverse of 2 power minus 4. So it is so simple. No, we know a power minus m is the multiplicative inverse of a power m. So for a multiplicative inverse 2 power minus 4 is very simple, that is 2 power 4. Just remove the minus symbol. And multiplicative inverse 7 power minus 2 is very simple, that is 7 square. Just remove the minus symbol. So now we learned how to write numbers like 1, 4, 2, 5 in the expanded form using exponents. So we have previously learned it. 1 into 10 cube, how to write expanded form. So let us now express for 1425.36 in the expanded form in similar way. So now we will do it, students. So what he has given, 1425. How 1425? We know this expanded form. How it looks like, that is 1 into how much, that is 1000, no, plus 4 into 100, no, plus 2 into 10, no, plus 5 into 1. So we are writing this as 1 into 10 cube plus 4 into 10 square plus 2 into 10 power 1 plus 5 into 10 power 0. So this is 1425 can be written as this in terms of powers, exponents. Now what is our task? Now what we have to write is, we have to write which thing, students? We have to express 1425.36 in a similar way. How can we represent it? 1425.36 in the expanded form. So how we can write those things? If there is a number is like that, how we can write that expanded form? So I will tell you, students, don't fear, I am here. Okay, students. So this is the expanded form. So just start here. So just start here. That is 1 into 10 power 4, we know already, plus 4 into 10 power 3, we know already, plus 2 into 10 square, we know already, but 5 into 10 power 0, we know already. Next you have to write again plus, and you have to start writing for the right side terms. That 3 into, what we have done here, we have goes decreasing powers. So simply you have to write it as 3 power minus 1. What happened? We have decreased the term. Next term, what is that? Is 6. Just write 6 into, again you have to decrease the power, that is 10 power minus 2. Why? Because we have coming decreasing the powers. So this is the simpler form of this. If you want the values of this, I will give the answer. That will becomes how much? This will becomes, oh sorry students, there is a mistake here, there is a mistake here. Here there is 3, here there is 2, here there is 1. No, previously I have written no. So like that, it here is 1000. It is equal to 4 into 100. It will becomes 2 into 10. It will becomes 5 into 1. Plus it will become 3 into 1 by 10. It will become 6 into 1 by 10 square. So we know no a power, since why? Because since a power minus m equal to 1 by a power m. So according to it, that implies according to 10 power minus 1 equal to 1 by 10, comma 10 power minus 2 equal to 1 by 10 square. We have written those like that. Now we are writing equivalent form for this. So 1000 plus 400 plus 20 plus 5 plus 3 by 10 plus 6 by 10 square what 100, so 6 by 100. So if you write these things again, 1000 plus 400 plus 20 plus 5 plus 3 by 10 is how much? That is 0.3 plus 6 by 100 is how much? That is 0.06. Okay students, now we have to add all those, then will becomes 1000. So while adding you have to make sure of about dots. Okay students, that is like that. 400 is, so we have to make sure of dot. If there is no dot in the number, then it is at the last after the ones place. We have to write like this. So next thing is 20, next thing is 5, next thing is 0.3, next thing is 0.06. Now we have to add those things. So this will become 6, this will become 3, there is a dot, and this will becomes 5, this will becomes 2, this will becomes 4, this will becomes 1. So this is the result students. So this is the what now we have started here now. So finally our LHS equal to RHS. So this is the correct answer students. So we can expand like this. So we can expand any number like this students. Okay, can you understand it? So we can expand it. Now we will do one more example here. So he has given two questions. I will do one question. So which you want? So I will do this question. 1025.63. 1025.63. How you will write? Just simple. How many digits are there? 1, 10, 100, 1000. So 1 into 1000 plus 0 into 100 plus 2 into 10 plus 5 into 1. This is the thing. Plus 6 into 1 by 10. 3 into 1 by 100. So we can write it as 1 into 10 cube. Plus it is 0 now, we can remove it. So this is 2 into 10 power 1, that is 5 into 10 power 0. Plus 6 into 10 power minus 1. Simply just remember, forgot these students. We will start writing with 10 powers only. Okay students, 6 into 10 power. Next there is 3, no, 3 into 10 power minus 2. We have to decrease our all powers. There is a term, but it is 0 now, we can neglect it. So this is the thing students. In this way you can find out. So how he had written it? Okay, first he has written it, and after that he has decoded it like that. So that's what we have written and rubbed. Now we have written this and we have rubbed this. We have routed here, that is like 1 into 1000 plus 0 into 100 plus 2 into 10 plus 5 into 1 plus 6 into how much? That is 1 by 10 plus 3 into 1 by 100. Like this we have right now. Then after that we have represented in this form. So we can write like this students. So we have to do homework for this. So students, finally we have discussed about the powers with negative exponent students. That's it students. We have completed these two topics. Hello students. Now we will discuss the laws of exponents students. Okay, how laws of exponents, and based on it we will do some problems students. Okay, so these are the example problems we are going to crack now. So that is the thing students. So laws of exponents. What are laws of exponents? So basically we have learnt that in the previous classes we have learnt a power m into a power n is equal to a power m plus n students. So here where m and n comma n are natural numbers, we are taking those as the natural numbers. They are not 0, they are starting from 1 and they are positive numbers. Okay students, so does this holds? So this formula still holds for negative numbers also? Does it still holds? Still holds for negative exponents or negative powers, also negative exponents, we want to check it. We will go and check it. Okay students, so basically here what is there, we know first thing is 2 power minus 3, we know that is equal to 1 by 2 power 3, and another thing is 2 power minus 2, we know that's value is 2 square. Now what will you do, we will multiply these two things, 2 power minus 3 into 2 power minus 2. So what is the value students, basically that's value is 1 by 2 cube into 1 by 2 square. So that will become how much, that is 1 divided by 2 cube into 1 divided by 2 square students. So this is looks like what, so basically it is looking like in the denominator it is looking like a power m into a power n. So we can write this a power m plus n. So we can write this 2 power 3 plus 2. So that becomes 2 power 5. Okay students, we know that is equals to 2 power minus 5. Therefore hence what we can write, 2 power minus 3 into 2 power minus 2. We have multiplied two negative, they are having same base and they are having the different powers or different exponents and whose exponents are negative numbers, and multiplying both these things we are getting a number that is having with the same base with 2 power minus 5. So finally how we can conclude that minus 5 is equal to minus 3 plus minus 2 now. So we can say that therefore a power m into a power n is equal to a power m plus n holds for negative numbers also, negative exponents also. So we can use this formula even though when m and n are natural numbers, or even though when an m and n are negative numbers, even though when an m and n are even though whenever m and n are positive integers or negative integers, in both cases this is valid students. Okay, next here there is one more thing students, minus 3 whole to the power of minus 4, minus 3 whole to the power of minus 3. Now we will do it for it. So from this what is our conclusion, it is holds for negative exponent students. Now we will do another experiment. So in this minus 3 whole to the power, how much they have given, minus 3 whole to the power of minus 4 into minus 3 whole to the power of minus 3. So in this we have to do the experiment students. We know that any power minus 4 is nothing but 1 by minus 3 whole to the power of 4. Next thing is 1 by minus 3 whole to the power of 3 students. So they are on the same under, no, there we can write this 1 by minus 3 whole power 4 into minus 3 whole to the power of 3 students. We can write like this. So after that, so according to a power m into a power n plus equal to a power m plus n formula, we can write those as the minus 3 whole to the power of 4 plus 3. So that will becomes 1 by minus 3 whole to the power of 7. So that will becomes minus 3 whole to the power of minus 7 students. So hence minus 3 whole to the power of minus 4 into minus 3 whole to the power of minus 3 is giving minus 3 whole to the power of minus 7 students. So what we can conclude, so minus 4 plus minus 3 equal to minus 7. So here also we can conclude that even the m and n are negative numbers, we can use it. So now 5 power minus 2 into 5 power 4. What happens in this scenario? So basically 5 power minus 2 into 5 power 4. So 5 power minus 2 is 1 by 5 square into 5 power 4. So that will becomes 5 power 4 by 5 square. So we can write 5 power, that will becomes, we know this formula now, according to that we have written students. So basically there is 5 power minus 2 into 5 power 4 students. So this is the third example. Now we will do it. So 5 power minus 2 is 1 by 5 square into 5 power 4. We can write it as the 5 power 4 by 5 square. So we know what we know, that a power m by a power n equal to a power m minus n. So we can write this as the 5 power 4 minus 2. That will become how much? That is 5 square. Okay student, that will becomes 5 square. So hence 5 power minus 2 or 5 power 4 by 5 power minus 2 is equal to 5 square. We have getting this. Minus 4 plus 2 equal to, so finally minus 2 plus 4 equal to 2 students. So here also we have getting the same result, students. Here minus 2 is there and plus 4 is there. When minus 2 plus 4 gives rise to 2, minus 4 plus minus 3 is giving rise to minus 3, and here minus 2 and minus 3 is giving minus 5. And by doing this example, you will get minus 4 plus 2 equal to minus 2, students. So in general, we can say that for any non-zero integer, a power m into a power n equal to a power m plus 1 when m and n are integers. So it is still hold. So finally a power m into a power n is equal to a power m plus n, students. So where it is a very important, students, m comma n, where m comma n are integers, where m comma n are integers, students. This is the thing, students. So we can take m as the positive numbers, we can take m as positive numbers, which means positive integers or negative integers, whatever it may be. For m comma n as positive integers, negative integers, whatever the integers may be, this formula is still hold, students. Okay, that formula is still holding. So this is the thing, students. So based on this, we will do some things, students. So you have to simplify these in the exponential form, students. So there is 2 power minus 3 into 2 minus 2 into minus 4 power 3. So we can write as the a power m into a power n. Then how will becomes, that is minus 2 into whole to power of m plus n. No, this is minus 3 minus 4. That will becomes minus 7. Simple thing, students. That is 1 by minus 2 whole to power 7. You can write like this also. Simply in this way you can write this also. There is p power cube into p power minus 10. So that will becomes p power 3 minus 10. That will becomes p power minus 7. Answer for this is why? Because 3 minus 10 equal to 7. Simply 3 minus 10 equal to minus 7. Okay, students, on the same lines you can verify the following law for exponents where a and b are non-zero integers and m and n are integers. So according to that formula, these formulas are also valid. You can check for these formulas also. So here also m and n are integers. For positive and negative integers of n, m and n values, all these laws are these laws have studied in class 7th for positive exponents only. Basically we have studied these laws in the class 7th for positive exponents only. Here we are applying for negative exponents also. So finally these laws are valid for integers, which means which are having positive number integers or negative integers, whatever the integers may be, all these are valid, students. So finally we will do some problem, students, simple problem. So let us do this problem. That is 2 power 5 divided by 2 power minus 6. So we can write it as 2 power 5 divided by 2 power minus 6. We can write, or simply we can write it as 2 power 5 divided by 1 by 2 power 6. No, so it will become how much? That is 2 power 5 divided by 1 by 2 power 6, which is nothing but 2 power 5 by so basically, students, simply we can do it. So we know a power m by a power n is equal to how much? A power m by a power n equal to a power m minus n. Now according to this formula, 2 power m by 2 power minus 6 is equal to the power of 5 minus of minus 6. So that will becomes 2 power 5 plus 6. That will becomes 2 power 11, students. So simple now. In that way we can do it, students. So now we will do here. Which you want, students? I will do here. It is looking somewhat difficult. So 2 power 5 divided by 2 power 8 whole to the power of 5, students. So we can write this as a power m by a power n is equal to a power m minus m. That is 2 power 5 minus 8 whole to the power of 5, students. So that is 2 power minus 3 whole to the power of 3, students. So we know According to a power m by a power n, it is a power m minus n. Here 2 power minus 3 whole to the power minus 5, that will becomes 2 power minus 15 students. Two power minus 15. Why? Because means a power n whole power n equal to a power mn. So we have discussed these students. Next thing is we have to multiply this 2 power minus 15 with 2 power minus 5. So that will becomes 2 power minus 5 minus 15 minus 5. That will becomes 2 power minus 20. So this is the answer now students, when it is 2 power minus 20. So next thing is, if you want anything in this way you can do students. Okay. So this is somewhat students somewhat looking difficult. I will tell you. Okay, there is minus 3 whole to the power of m plus 1 into minus 3 whole to the power of 5. That is equal to minus 3 whole to the power of 7 students. Okay, so in this example how we can do it? So these are the things of a power m into a power n equal to a power m plus n now. So according to this, minus 3 equal to m plus 1 plus 5 is equal to minus 3, 7. So how we can write it as minus 3 whole to the power of m plus 6 is equal to minus 3 whole to the power of 7. Since bases are equal on both sides, we can equate the powers. So m plus 6 equal to 7. From this we can take 6 to that side, shift to that side, that is called m plus equal to 7 minus 6, that is called m equal to 1 students. So finally we have find out the value of m. Okay students, finally value is 1 students. So now I want to do this problem students to help you, or whether you want this. So I will do this. It is somewhat difficult now. So first we will solve the numerator. After that we will solve the denominator students. What is the numerator? That is 1 by 3 whole to the power of minus 2 minus 1 by 2 whole to the power of minus 3. That is minus 2. Here it is minus 3. So we will solve this numerator. So basically the answer, the question is, it is divided by 1 by 4 whole to the power of minus 2. Now just we will take numerator. That is 1 by 3 whole to the power of minus 2 minus 1 by 2 whole to the power of 3. How we can do is, so that is equal to how much? Whenever, so we can write it as a power m by a power n. That is 1 to the power of minus 2 by 3 to the power of minus 2. Simply here also 1 cube by 2 cube. So if you do this, we know 1 power minus 2 is 1 and 3 power minus 2 is, that is 1 by 3 square. So, or just simply leave it as 1 by 3 square minus 1 divided by 2 cube. Okay students, so this 3 power minus 2 will becomes 3 power 2 whenever it goes to up, which means that is 1 divided by 3 power 2 now minus 1 by 2 power 3. So it will becomes how much? It becomes 3 square minus 1 by 2 cube. Okay students, it will looks like that. So 3 square is 9 and 2 cube is 8. Okay students, 3 square is 9. So here basically what is happening students? Here minus 3, no, not 3, minus 3, minus 3. So what happens whenever there is minus symbol? Here also there will be minus symbol. So it will becomes 1 by 2 cube, no. So this will change students. I have forgotten the minus symbol. So it will becomes 3 square minus 2 cube, which will becomes 9 minus 8, whose value is 1 students. So this is about all the value of numerator. So that is equal to 1 divided by here 1 by 4 power minus 2 now students. So now we will solve the denominator. We will solve denominator here. 1 by 4 whole to the power of minus 2. That will becomes 1 by minus 2. 4 to the power of minus 2. That is 1. This is 1 by 4 square. So it will becomes 4 square. That is equal to 16. For denominator value is 16. So that will become 16. So whole answer is 1 by 16 students. That's it students. So simple. So we have understood what are laws of exponents. So basically these laws, a power m by a power n equal to a power m minus n and a power m by b power m equal to a by b whole power m. and a power 0 equal to 1, a power n whole power n equal to a power m into n, a power m into b power n equal to ab whole power m. So all these rules are we have studied for positive integers. Here we have studied for positive or negative integers. They are true for all integers. Okay students, we have completed this topic. Basically we discussed this topic students. Use of exponents to express small numbers in standard form. So how to express small numbers in standard form using exponents students. So basically observe these facts. What is the facts? The distance from earth to sun is 1, so it is so big number we can't read it. So this is also big number, we can't read it. So this is 20 mm, we simply read it. This is 0.05 centimeters. This is 0.001 13 centimeters. So by observing all these numbers, what we can say that there are few numbers like 2 centimeters, 8,848 meters and 6,95,000 kilometers. These are the few numbers. We can read it, we can call it. But there are numbers like this, we can't. It takes some time, and numbers like this we can't speak them, or we can't count them. It takes some time. No, so these are numbers like that students. So identify very large and very small numbers. We have to identify very large and very small numbers. So this is the small number and this is the very large number. So we have to identify both these numbers from these figures, and you have to write like this. So 1 lakh is, it is the biggest number, very large number. This is the smallest number students. So in the previous class we have learned how to express larger numbers, how to express large numbers in standard form. That is the thing we have learned in previous. Now we will learn how to express small numbers in standard form. So here we are taking an example of 0.000007. How many zeros? 1 2 3 4 5 1 2 3 4 5 5 zeros are there. So this is the small number. How to represent it? So basically you have to write it as 7 divided by. So we know 1 by 10 is how much? That is 0.1. 1 by 100 is how much? That is 0.01. So by observing this, if there is 0.1, it becomes 1, which means 1.0. Here also 1.0. So basically before 0.1 is converting into 1.0. What happens? There is 0. What happens? This dot is shifting right. This dot is shifting right. Whenever it is shifting right, whenever we are dividing it with, so whenever this number is divided with this number, that is shifting left. Okay students, can you understand it? So similar way, or justly take, suppose if there is a 0.1, if you want it to write in a division form, how to have, you have to write before number, there is the dot is before the number, so we have write just 10. Here the dot is before two numbers, you have write the 100. Suppose 1 divided by 1000 is there. So here the dot is 3 numbers before the 1, so we have write it as 1 by 1000. Similarly, how many numbers are there? There are 1 2 3 numbers, no, 3 zeros. 1 2 3 4 5 6 numbers. 1 2 3 4 5 6 numbers before is there, so we have to write 6 zeros in the denominator. 1 2 3 4 5 6. Similarly here 1 2 3 dot is where? Before 3 digits, so we have divided with 3 zeros. Here 2 digits, 1 2, so 2 zeros. Only 1 digit, so 1 0. Like that we can write 0.00 like that as 7 by, how we called it as 10 lakhs. 10 lakhs students. We can write it as in this form students. So this will becomes how much? Oh, that will becomes 10 power how much? How many zeros? 1 2 3 4 5 6. 10 power 6. We can write it as 7 into 10 power minus 6. So this is the standard form students. Okay, we can write in this way. So basically for converting this to this, we can write this by counting digits, how many after the dot, how many digits are there, then you have to add that much of zeros. Or if you, this is the simplest shortcut way. Just count the how many numbers after digit and multiply with that number of zeros. Very simple way. Okay, students, you will get like this. So decimal is moved 11 places to the left. Here decimal is moved 6 places to the right. So what happened here? The decimal is moved. It is 7.0 now, which means the decimal has moved 6 places. How many digits? 1, 2, 3, 4, 5, 6 digits now. So whenever we are dividing with multiplying with that, you will get 6 digits. So 1, 2, 3, 4, 5, 6. After 6 digits, you have to write 6 zeros. Okay, students. Similarly, for there is one other number 0.0016. So we have to write how, like we have to write there is 1, 2, 3, 4 digits. No, we have to for 4 digits you have to shift. Then you have to write 16 divided by 4 zeros. Simple. So then it will become 16 divided by 10 power 4. It will become 16 into 10 power minus 4, students. Okay, if you want, if you can do further also. So we can write we can write 16 as 1.6 into 10 also. Okay, students, then that is equal to 10 power minus 4. Finally it will becomes 1.6 into 10 power minus 3. You can write like this also, students. Okay, students, so this is the standard form. What happens? 1 by 6 is how much? That is 16 by 10. So 16 equal to 1.6 into 10. That's what we have written. We have written 16 is equal to 1.6 into 10. Okay, students. So in this way we can write smaller numbers in the standard form, students. Now we will write this. There is 0.00. How many zeros? 1, 2, 3, 4, 5 zeros. 3, 4, 5 అయిపోయింది 2, 1. So the dot have to moved. How many digits it have to moved? 1, 2, 3, 4, 5, 6, 7. 7 places it have to be moved. So we have to write it as 21 divided by, we have to put 7 zeros. 1, 2, 3, 4, 5, 6, 7, students. So that will become 21 divided by 10%. That will become 21 into 10%. We can write 21 as equal to 2 power 1 into 10 into 10 power minus 7. Here there is minus 7. So it will become 2.1 into 10 power minus 6, students. This is the simplest form. In this way you can write these, students. Next thing is comparing very large and very small numbers. How we will compare very large and very small numbers? So basically the diameter of sun is 1.4 into 10 power 9 meters and the diameter of earth is 1.2756 in 10 power 7 meters. If you want to compare both these things, how you will compare both these things? So for that we have to divide diameter of sun by diameter of earth. That is 1.4 into 10 power 9 divided by 1.2756 into 10 power 7. 10 power 7. So that will becomes 1.4 into 10 power 9. We have to take this to numerator. That is 10 power minus 5 divided by 1.27. So that will becomes 1.4 by 1.2756. No, 2756 into how much? 10 power 9 minus 27 means that is 100. So finally, therefore what we can time, that is, therefore diameter of sun is about 100 times the diameter of so basically I will explain you, students. Wait a second. So here there is diameter of sun. Denominator is diameter of earth. If you take this earth to this side, finally diameter of sun is equal to 1.4 by 1.2756 into 100 into diameter of earth, students. So from this what we can say is, so 1.4 by 1.2 is very small number, we can neglect it. So diameter of sun is how much? That is equal to 100 into diameter of earth. So diameter of sun is equal to 100 into diameter of earth, which means diameter of sun is 100 times diameter of earth. I am neglecting the word diameter. Diameter of sun is 100 times diameter of earth. Why? Because if you want the diameter of sun, that is 100 into diameter of earth, no, like that, students. So in this way you can compare the two numbers. Again, if you want to compare the red blood cell, size of red blood cell with plant cell. So red blood cell is what? Size of red blood cell, size of red RBC, that is equal to 0.0000. How many zeros? 1 2 3 4 5 zeros. 7. We can write it as 7 divided by, we have to write 5 zeros, no, not 6 zeros. 1 2 3 4 5 6 places after dot, so that is 7 into 10 power minus 6, students, maybe meters. The next thing is plant cell, P cell, that is how much? That is 0.0000. How many zeros? 1 2 3 4 1 2 7 5. So we have to write it how much? That is, if you want to shift dot to this place, how many dots, how many places you have to shift? 1 2 3 4 5 places you have to shift. Then for that you have to write 1.275 divided by 5 places. Now we have to divide with 5 zeros. 1 2 3 4 1 2 3 4 5. Then it will becomes 1.275 into 10 power minus 5. Now again, if you divide both these things, that is 7 into 10 power minus 6 divided by 1.275 into 10 power minus 5. Whenever you are taking numerator to this side, 1.275 into 10 power minus 6 and minus 5, it will becomes how much? That is 10 power minus 1. So it becomes how much? That is equal to 7 into 1 by 10, or we can write it as the 0.7 divided by 1.275. So approximately 0.7 divided by 1.3. Approximately how much it is? It is 1 by 2. Approximately 1 by 2. So therefore red blood cell size divided by plant cell is equal to how much? That is 1 by 2. If you want so take to this side, to shift to this side and to this side. So 2 into size of red blood cell is equal to 1 into size of plant cell, which means therefore size of plant cell is twice or 2 times of red blood cell. That is the thing, students. In this way you can compare. Okay, students, approximately. So here the mass of earth is like that and mass of moon is like that, students. So what is the total mass? So in the case of addition or subtraction, one thing you have to do, when we want to add two numbers, add or sub two numbers in standard form, what we have to do? We have to have same powers, same 10 powers or exponents, same powers or exponents, or So we will do some example, after that we will check it. We have to, whenever, so when we have to add two numbers in standard power, we convert them into the numbers with the same exponents. What we have to do, we have to convert them into numbers with same exponents. So whenever there are same exponents, you can add or subtract. You can add or subtract. So whenever there are same exponents, then you can add or subtract. What maybe you can do. Suppose mass of earth plus mass of moon. No, basically mass of earth and mass of moon, that is 5.97 into 10 power 24. No, so I will do here, simply I will do here, I will take space, students. No, don't worry. 5.97 10 power 27 kgs, 5.97 20 power of 24 kgs plus 7.35 into 10 power 22 kgs, 7.35. kgs. So basically here, if you see, there is a power exponent of 24 and there is exponent of 22. So we can't add both these things. So we have to have the same exponents. For that, what we have to do, we have to bring those as the same exponents. So we can simply do 5.97 into 10 square into 10 power 22. Okay, students. So we can plus 7.35 plus 10 power 22. So 10 square is how much? That is 100. So 5.97 into 100. We can, whenever we are multiplying this with 100, how it will get? That is 5.97 into 100. No, that will give how much? It will give 597. So this will becomes 597 into 10 power 22 plus 7.35 into 10 power 22. So they are having both exponents, no, both same exponents. So we can do that 597 plus 7.35. So whenever there are same exponents, you simply add these two things, 597 plus 7.25, and you can simply multiply with this same exponent, which means we are taking common this same exponent. So adding these two things will give us some answer, and that will give rise the answer like that, 6.04.35 into 10 power 22 kg, students, simply by doing this. So this is the case when we are adding. So if you want to subtract also, this is the case when we are adding. So when you want subtracts, so in this case also same procedure. What you have to do, again you have to make both are having same exponents, then you can simply subtract these coefficients. That's it, students. So now I will do some example here. So express the following numbers in usual forms. How to represent these in usual forms? 3.52 into 10 power 5. So that is how much? 3.52 into 10 power 5 means we have to have 5 zeros. 1, 2, 3, 4, 5. So simply what happens? 3.52. So whenever we are multiplying with 5 zeros, the dot will shifts 5 places. That is 3, 5, 2, 0, 0, 0. So it is moving 1 place, 2nd place, 3rd place, 4th place, 5th place. This is the placements. So this is the way. If we are taking about this 3 into 10 power minus 5, which means how much? That is 3 divided by 10 power 5. So that is equal to 3 divided by 10 power 5 means after 1 there are 5 zeros. 1, 2, 3, 4, 5. Okay. So whenever there are 5 zeros, what happens? The dot will shift left 5 digits. So that is 0.00003. 5 digits. It has shifted towards left like this, students. So this is the thing, students. We have completed the chapter. So finally, what is thing? Our chapter is completed. Chapter completed. Now we will have the summary of the whole chapter. Summary. Okay, students. So exponents and powers is our chapter and introduction. So we know whenever there are powers are positive exponents, we know how to solve it. So whenever the powers are negative exponents, how we will do it? Simply, what is our logic? Simply, whenever there is 10 power minus 2, we have to write it as 1 by 10 square. 10 power minus 3, we have to write it as 1 by 10 cube. 10 power minus 7, we have to write it as 1 by 10 power 7. So finally, what is the thing is a power minus m. So we can simply write as a power minus m equal to 1 by a power m. So this is the thing, a power minus m equal to 1 by a power m. M is a positive integer, a is a non-zero integer, students, and a power minus m is multiplicative inverse of a power m, students. Okay, and we have learned how to write numbers in expanded form. After that, laws of exponents. We know a power m into a power n equal to a power m plus n. So this is basically for natural numbers. But after doing these examples, m and m, even though this law holds for integers, for positive numbers and negative numbers. So there are basically all these laws. A power m by a power n equal to a power m minus n, a power m by b power equal to a by b whole power m, a power 0 equal to 1, a power m whole power n equal to a power m into n, a power m into b power m equal to a b whole to power m. All these are valid for positive integers or natural numbers in the previous class. But here what we have discussed is all these are valid for integers, which means for positive integers, for negative integers. So that's what we have learned here, students. Finally, this is applicable for a power m all integers. After that, we have solved some problems. After that, we have studied how to express small numbers in the standard form. After that, we have know how to compare large and small numbers. So whenever we are adding two numbers, we have to shift them or convert them into numbers with same exponents. Then only we can add and subtract. So that is the whole thing, students. Our chapter is completed. Our summary is also completed.